This is the fifth video of our unit on cell respiration, but we still haven't talked about cell respiration. In this video, we're going to lay more groundwork to understand cell respiration by talking about an important type of chemical reaction called a redox reaction. This video is going to help accomplish this course goal right here. You're going to be able to explain what happens during a redox reaction and give examples. Now, this video will show you how a redox reaction works, but the examples will come later in the unit and in our photosynthesis unit. When we think about cell respiration, it's important to remember that cell respiration is really just a series of chemical reactions. Since cell respiration breaks down glucose and releases energy from glucose in our food, cell respiration is just a series of catabolic, exergonic reactions. And these reactions drive the, endergonic is what that's supposed to say, endergonic formation of ATP. Right here, you can see the overall equation for cell respiration. And this is an important one that you're going to have to remember, but I'll give you some tips on how to remember that in class. But basically what we have here is glucose plus oxygen reacting to give carbon dioxide, water, and ATP. If you remember your days in chemistry when you had to classify chemical reactions, this reaction right here would be classified as a classic combustion reaction. Burning things is also a combustion reaction, so organisms technically burn glucose with cell respiration, but without all of that fire. The big difference with cell respiration is that cell respiration spreads the energy release over many chemical reactions, so energy is released just a little bit at a time. Each step of cell respiration, and all metabolism for that matter, is driven by an enzyme. The reactions of cell respiration happen in a sequence, one right after another, just like in this diagram right here. So, you can think of enzymes as just being in a chain, where the products of one enzyme become the substrate of the next enzyme in the chain. Having multiple reactions in a row like this has some advantages. One advantage is it releases energy in usable small bits, one right after another. Also, having the reactions in a chain like this helps for regulation. There's more chances for regulation at each step. Also, some of these intermediate products along the way are actually used as building blocks for other reactions. Now, let's get to the main purpose of this video. The main purpose is to introduce you to a common type of chemical reaction in cell respiration called a redox reaction. Redox is an abbreviation for oxidation reduction. In a redox reaction, electrons are transferred from one molecule to another. Maybe transferred doesn't quite capture what's going on because electrons are actually kind of stolen. Remember in our biochemistry unit, we talked about electronegativity, a measurement of how strongly a compound or an atom attracts electrons. And that's indicated by these numbers right here. Well, in redox reactions, electrons are shuffled from a compound with lower electronegativity to a compound with higher electronegativity. An acronym that will help you remember what happens during a redox reaction is right down here, OIL-RIG. OIL stands for oxidation is loss, and RIG stands for reduction is gain. Let's look at a simple example and put this knowledge to work. This example is the formation of sodium chloride compound from sodium and chlorine atoms. Remember, because nature loves stability, sodium and chlorine atoms both want to have an octet of valence electrons to fill their outer electron shell. To do this, sodium gives up its valence electron to chlorine, as shown on here, and that forms an ionic bond. But electrons have been transferred. The transfer of electrons from one molecule to another, or one atom to another, is a redox reaction. So let's think of this as a redox reaction. Now, to keep track of what's going on here, we're going to use the mnemonic OIL-RIG to help us. The first question here asks, what is oxidized? Remember, oxidation is loss. So sodium is oxidized because sodium lost an electron to chlorine. Well, what is reduced? Reduction is gain, and in this process, sodium lost an electron, but chlorine gained that electron. Chlorine is reduced. There are two more terms we want to keep straight: oxidizing agent and reducing agent. An oxidizing agent is the compound that is taking the electron. In this case, the chlorine atom is the oxidizing agent because chlorine is oxidizing sodium, or taking the electron away from sodium. If we reverse that, we get the term reducing agent. The reducing agent is the compound that gives up the electron. In this case, sodium is the reducing agent because sodium is reducing chlorine. Sodium is giving up this electron for chlorine to gain. If that's confusing, stop this and rewind it about 90 seconds and watch this again. Also, we'll be doing some practice in class, and we'll see this again and again throughout the chemical reactions of cell respiration. In cell respiration and photosynthesis later on, there are so many redox reactions. We're going to meet two compounds when studying cell respiration called NAD and FAD. Both of these are good electron stealers. NAD and FAD steal electrons from glucose. This means that NAD and FAD are oxidizing agents. They oxidize glucose. In the process of cell respiration, NAD and FAD are reduced when they gain those electrons from glucose. Another really good example of a redox reaction in cell respiration involves oxygen. As the final step of the electron transport chain of aerobic cellular respiration, oxygen is the final electron acceptor. Oxygen is literally the ultimate oxidizing agent of aerobic cellular respiration. But, confusingly, in this process, oxygen is reduced when oxygen gains those electrons. So, what do redox reactions have to do with energy? Remember, redox reactions involve the transfer of electrons from one molecule to another. In cell respiration, think of these electrons as high-energy electrons. Each time a high-energy electron changes hands or gets transferred, there's a little bit of energy that's released. These little bits of released energy are ultimately what are used to phosphorylate ADP to make ATP in cell respiration. You can think of each reduced compound as a temporary energy storage compound until the reduced compound does its next redox reaction and releases a little bit of energy. So right now I bet you're thinking, Dr. Wallace, I signed up for AP Bio and not AP Chem. What is this? Well, let's take a breath and review the high points. First, cell respiration is a series of enzyme-catalyzed reactions. Okay, not so bad. Second, oxidation reduction or redox reactions happen when one molecule transfers electrons to another molecule. Hopefully that's not too bad by itself either. Third, in cell respiration, redox reactions release energy of glucose in little bits at a time, small, meaningful quantities in the process of making ATP. Now we've laid a lot of groundwork down to talk about aerobic cellular respiration, and that's what we're going to start with in our next video.